Hey, welcome. We're taking a look today at data classification. So we've got all this information about a population or a sample, and what do we do with it? We want to be able to order it. We want to talk about it. We want to group it in different ways depending on what it is. So that's what we're going through today. A few vocab words to get started on. The first is variable. A variable is the data that is being measured. So if you think about our example from last section, we want to talk about like the average height of the people at our college. The variable are the heights. That's the data that we're measuring. There's two kinds of data. They are generally broken into two categories: qualitative data and quantitative data. So qualitative data is non-numerical entries. So numericals, mathy word for like it's not numbers. So for example, qualitative data, what might be, if I'm asking you, what's your favorite kind of food? You're going to answer pizza, hamburger, sandwich. That's going to be qualitative data. Quantitative data is numerical. So this is everything else. You want to know your height, your weight, your blood pressure, how many pizzas you ate last week. This is all quantitative data. If your answer is a word, it's qualitative. If your answer is a number, it's quantitative. The way I remember that is quantitative has this part of a word right here, quant, like quantity. So if I'm going to measure a quantity, that's usually like a number. That's my remembering aid for that, for what it's worth. Okay, now let's take this qualitative and quantitative and let's talk about the level of data. There are four different levels of data. The first is called nominal. Nominal data is only qualitative. So no numbers can be used in nominal data. It will only be word data answers. And the way that you classify something as nominal is you ask the question, can it be ordered or can you do computations with it? Okay, so for nominal data, there is no order and you can do no computations. And by computations, I mean, you can't do any math with it. You can't subtract the entries. You can't multiply by 2, that kind of thing, because they're words. So that makes sense. So back to the example of what's your favorite food, that would be considered nominal data because it's not numbers and you can't order it. Pizza's not in any specific order, like order doesn't make sense when you're talking about pizzas or hamburgers. Okay. So here's some examples of nominal data. We'll just write some out. You know, what we just said, favorite food. You could do TV show, could be this movie genre, right? Like action or drama. There's no order to those two categories. They're words and they can't be put in any specific order. So that's how you qualify nominal data. All right. Next data level is called ordinal. Ordinal can be qualitative or quantitative. Okay, so this one's, you got to kind of pay attention to more than just, is it a number or not, to be able to classify it in that ordinal category. So the question here is, for ordinal data can be ranked or ordered. Okay, but you cannot calculate a meaningful difference between entries. Okay, now difference, let's talk about that. This is a mathy word that means subtract. So, for example, if I tell you that the temperature today is 70 degrees and yesterday it was 60 degrees, it makes sense to subtract those two numbers, because when you subtract 70 minus 60, you get 10 degrees. So it makes sense for me to say today it was 10 degrees warmer than yesterday. Okay, that's an example of something that's not ordinal, because you can subtract the values. Okay, so however, if I say, here's the top 5 movies from last year, it doesn't make sense to subtract movie names. Okay, so let's take a look at some examples. Let's look at this movie name. Let's see, let's say top movies of the year. Okay. So you're going to list out the top movies of last year. They can be ordered. So here, they can be ranked or ordered. They can be, because here's your top movie, here's your second movie, here's your third movie. Those orders make sense, whereas they don't with the pizza hamburger situation. Okay. But I can't subtract the movie names from each other. So that's the difference issue. So when you're looking for something, a set of data to be ordinal, you're checking two things. The first thing that you're going to do is, can I put it in an order? Does that make sense? So anytime I say top blank of anything, you're at least ordinal, because there's a ranking involved. Okay, now let's take the favorite food scenario. If I say, what's your favorite food? And I survey the whole class, what's all your favorite foods? That can be ordered, because then I'm comparing your favorite food to somebody else's. Okay, but listen to the change in question. If I say, list your 5 top foods, now that's ordinal data, because I'm going to you and saying, I want you to rank food 1, 2, 3, 4, 5. Okay, so if you're giving me one data value, I obviously can't rank that, okay, for you. But if you're going to give me 5 of them in order of some sort, least to favorite or vice versa, then all of a sudden it's ordinal. So the way that I phrase the question matters. It's not the topic of food that makes it nominal, it's how I phrase the question. Okay, another example of ordinal data: birth orders. Okay, so if I say I'm the firstborn, I'm the secondborn, I'm the thirdborn, there's an order to that, but it doesn't really make sense that we would subtract birth orders. That's not something that would be interesting or useful. Okay, so it's, again, this idea of there's an order to it, but we're not actually doing calculations with those numbers or topics. Okay, so that's ordinal. The next one is called interval. This can be quantitative only. So remember, quantitative means numbers. So an interval data level only has numbers in it. So if you are getting data values that say pizza, hamburger, it can only be either nominal or ordinal. It cannot be interval. Now, if you get data values that are numbers, then we jump into, okay, it could be interval. And here's how you tell. For interval, the difference between entries, remember we just talked about that, makes sense. Okay, so there's two things that classify something as interval. The first is difference of entries makes sense. The second is that 0 does not mean none. Okay, now let's talk about what this means. Let me give you an example and we'll explain in context of the example. Let's look at temperature. Okay, let's do Fahrenheit as an example. So I'm going to say that it's 70 degrees outside. And then today and yesterday it was 60. So the difference between entries makes sense, right? It's 10 degrees warmer today than it was yesterday. That puts it in this potential for interval. But now I have to check my second thing. Does 0 mean none? Okay, so let's talk about 0. If I say that it's 0 degrees outside, does that mean there is no heat? That's the question, okay? Now, one clue that often happens is if you can go into negative numbers, most often 0 does not mean none. Okay, so I can say it's 0 degrees out, but I could also say it's negative 32, right? So 0 is not the bottom of the line. That's not the end of the story. You can actually go lower than that. So in that case, 0 does not mean none. Now let's compare that to something like weight. When I say I weigh 100 pounds or 110 pounds, that you can calculate that difference. Okay, so again, difference has meaning and makes sense. But now when I say that something weighs 0 pounds, that actually does mean that there is no weight, right? There's no such thing as negative weight. So 0 is as low as you can go when you're measuring weight, and it goes up from then. So in that case, 0 actually does mean none. So weight is not an interval measurement, okay? So temperature, because you can go below, temperature is interval. 0 does not mean none. Okay, I know that's like a lot of negatives and like doesn't not mean, okay? So if you need to pause the video, rewind that and listen to that again, okay? And be careful with that. Another example of an interval measurement is dates. So let's talk about like years. I'm going to put years here. That's what I mean by dates. So this year, you look at a year that something occurred, say something happened in 1997 and something else happened in 1990. That's 7 years apart. So the difference makes sense. The difference between 1990 and 1997 does make sense. A difference has value and meaning. However, if I say the year is 0, 0 is not the beginning of time because our calendar is divided at the birth of Christ. We counted up to that point, and then we started at 0 and we count up from there. Okay, so the year 0 is actually not the beginning of time. So 0 does not mean none. Okay, now if we had started counting time from the origin of all things, then years would not be interval. But because we changed that date line and put 0 in the middle, in essence, there's like negative and positive numbers kind of in that situation, okay? So that makes the data interval on dates. All right, and then the last one is ratio. Now, ratio, 9 times out of 10, if you get a number data, it's going to be ratio. So if you have to guess, you guess ratio. Okay, it's more limited amounts of data that are in the interval classification. A ratio is also quantitative only. Okay. It can be ordered. So this is, again, your qualifications. It can be ordered, which, you know, interval can too, okay? The difference makes sense. So this is just like, oh my gosh, I can't spell that. Hold on, let me try again. Sense. Is that an S or a C? I think it's an S. Spelling is not my strong point. Difference makes sense, okay? The third qualification is 0 means none. Okay, so 0 is actually 0. Okay, and then the fourth thing is the phrase twice as much makes sense. All right, so let's look at this. Weight. If I weigh 100 pounds and you weigh 200 pounds, you do weigh twice as much as me. That makes sense. That's what that last sentence means, twice as much. So if you take 2 times, that is actually twice as heavy, okay? Now compare that to temperature, which we know from the last example is an interval. When I say it's 10 degrees out and 20 degrees out, 20 degrees is not twice as hot as 10 degrees. It's still cold. Like it's all cold. It's not, it isn't measured like the 2 times the number is not actually 2 times the actual amount of heat. Okay. So that's the additional thing. Now, anything that you're going to measure, like height, weight, blood pressure, anything that you're measuring with a ruler, it's all ratio. Okay. Because let's think about it. Like if you're measuring the length of something, if something's 10 centimeters or 20 centimeters, the 20 centimeter thing is twice as long as the 10 centimeter thing, right? It's proportional, 10, you know, twice as big. Also with measurement, 0 means 0. There's no negative length to things. Okay. So anything that you're measuring is going to be ratio. So, I mean, there's like a ton of examples with this. This is going to be like average rainfall. I mean, I cannot write all the examples because there's a million. Height, weight. You could even do like total home runs for a baseball team, right? Let's look at this one, total home runs. Let's see if it classifies. Can it be ordered? Yes, right? Like 1 home run, then 2, then 3, then 4. There is an order to that. The difference makes sense. If I have 10 home runs and you have 5, then I had 5 more than you. The difference makes sense. 0 means none. If I get 0 home runs, that means I didn't get any. Yes. Okay. And twice as much. If I got 10, you got 20, then you got twice as many as me. So it checks all of these boxes over here. So here's how I run a scenario through. If somebody gives me a set of data and asks me what is the data level on it, I start here at nominal. Okay, I go, let's see, I first check, is it qualitative? If it's not qualitative, then it's not nominal. Okay, and then I go to the next one. Then I go to ordinal. I check that. These are in order. Okay, so you start at the beginning, check nominal. If it's not nominal, then you go to the next one. You go to the next one until you find the, you know, well, it meets this qualification, but not this one. That's where you stop. Okay, so you go through and you just check all of these components and they build on each other. And that's what you'll be asked to do in your homework. All right. Thanks for tuning in. I will see you next time.